Welcome to the severe weather analysis for Perth, Western Australia. This is Thursday, November 27th, 2025, analysing the 8 a.m. morning sounding. If you find this analysis helpful, please like and subscribe to support continued severe weather analysis. Looking at this morning's atmosphere over Perth, we are seeing a very stable environment with essentially zero convective energy. Mixed layer CAPE is 0 joules per kilogram, and surface-based CAPE is barely 2 joules per kilogram, which is effectively nothing. The mixed layer lifted index is strongly positive at plus 14.3 degrees Celsius, confirming very stable air. On the Skew-T diagram, we can see the red temperature line and green dewpoint line are quite separated near the surface, with a 9-degree dewpoint depression indicating relatively dry low-level air. There's a strong inversion layer between 825 and 781 hectopascals, where temperature actually increases with height by nearly 8 degrees. This inversion is acting like an impenetrable ceiling, preventing any vertical motion. The lifting condensation level sits at 1,168 meters above ground. Precipitable water is 14 millimeters, which is quite low for Perth. Despite the lack of instability, we do have impressive wind shear, with 0 to 6 kilometer shear at 32 meters per second, but without energy to tap into, this shear has nothing to organize. As we heat the surface parcel to the forecast maximum of 19 degrees Celsius this afternoon, we see minimal transformation. The enhanced Skew-T plot shows the blue shaded area representing convective inhibition dominating the diagram, with only a tiny sliver of pink shaded CAPE appearing near 800 hectopascals. Surface-based CAPE barely increases to 8 joules per kilogram, which remains far below the threshold needed for convection. The strong inversion between 825 and 780 hectopascals persists unchanged, as environmental profiles don't change with solar heating. The lifting condensation level rises slightly to 1,423 meters. Even with afternoon heating, there's simply no pathway for air parcels to rise through this stable layer. The supercell composite parameter remains near zero at 0.02, and significant tornado parameter stays at 0.01. Allen's discriminant for Australian thunderstorms comes in at just 2,693, far below the 18,000 threshold for storm initiation. The hodograph tells an interesting story about the wind structure aloft. We are seeing strong directional shear, with winds veering from light southwesterly near the surface to strong westerly flow at upper levels. The wind profile shows increasing speed with height, reaching over 40 meters per second above 6 kilometers. 0 to 6 kilometer bulk shear is 32 meters per second, which would be excellent for organizing severe storms if we had instability. Storm relative helicity is 230 meters squared per second in the lowest kilometer, and 384 in the lowest 3 kilometers, indicating curved wind profiles favorable for rotation. The right mover vector points south-southwest, meaning if supercells were to develop, they would track in that direction. The left mover points northeast. However, all this impressive shear structure is academic today, as there's no fuel to power convection. It's like having a perfect racetrack but no cars to drive on it. The Bruntweisler frequency profile, or n-squared profile, gives us a detailed look at atmospheric stability. We are seeing elevated duct conditions in the orange-shaded band between 1,500 and 1,900 meters, which corresponds to the strong inversion we identified earlier. This layer has very high static stability, acting as a waveguide that traps energy rather than allowing vertical motion. Below this elevated duct, near-surface refractivity is relatively normal. Above 2,000 meters, the atmosphere shows typical stratification with n-squared values decreasing gradually with height. The sharp spike in the n-squared profile right at the inversion base confirms this is an extremely stable layer. This visualization clearly shows why convection cannot occur today. There's a fortress of stable air blocking any upward development. Any attempt by a parcel to rise would encounter this wall of stability and be forced back down. Today's analysis shows Perth under a stable, subconvective regime with zero thunderstorm potential. Strong wind shear exists aloft, but without instability, severe weather is not possible. Always consult the Bureau of Meteorology for official warnings and forecasts at bom.gov.au. This analysis is provided by Distant Curve Remote Area Telecommunications. If you found this helpful, please like and subscribe to support continued severe weather coverage for remote Australia.